Welcome to Ask and Learn.
In this problem, we're told that we have two carts. One is twice as massive as the other. They fly apart when the compressed spring that joins them is released. We want to know what the acceleration of the heavier cart relative to that of the lighter cart is. So we have our two carts here. Lighter one here, heavier one here. This spring is compressed, so it's generating a force. We can isolate everything from the environment and from the other elements in the system. So we isolated our first cart here. We have gravitational force acting down, force from the floor holding it up, a force from the spring on the cart. We look at the spring. We have a force from the cart, the first cart on the spring, a force from the second cart on the spring, and finally, if we look at our bigger part here, we have its gravitational force acting down, the floor holding it up, and then the spring force, the force from the spring acting on it. We know that F1 has to be F2 because of Newton's third law. We also know from Newton's third law that F3 has to be F4. And then, because this spring has no mass, these forces have to be equal to one another. So all the forces, F1, F2, F3, F4, have to all be equal to one another. So we'll just call them F. Right? Newton's equations for the motion of these two blocks, we have that the force, F, F1, equals the mass of this block times its acceleration in the horizontal direction. And then F4 is actually in the minus direction. So F in the minus direction is 2 times the acceleration, the mass, times the acceleration of this block because it has twice the mass. If we do a little algebra then, we can see that A1 is minus 2A2. So A2, the acceleration of the heavier block, is half of the acceleration of the lighter block and in the opposite direction. So its magnitude is half of the magnitude of the lighter block.